lecture, we are going to discuss about the internal block structure of a 8051 microcontroller. We all know that what is a microcontroller. It is otherwise known as an embedded controller. In my previous lecture, I have discussed about what is a microprocessor, what is a microcontroller, and the comparison of microcontroller. Today we are going to discuss about the 8051 internal block structure. What is this 8051? Is that it is an 8-bit IC. Okay, it is a 8-bit IC. Since it is an IC, how many pins this IC have is it has 40 pins. Okay, among these 40 pins, 32 pins are IO pins. And 2 pins are plus 5 volt supply, that is VCC, and ground. Another is a reset pin. Other 5 pins are for interrupt, that is for timing circuit. Okay, that is timing circuit is that enable access, address latch enable, program store enable, and other 2 pins are for oscillator circuit, that is XTAL1 and XTAL1-2. Okay, these 32 pins are IO pins. Total 40 pins we are having. These are the 40 pins of an 8-bit IC, that is a 8051 IC. Today we are going to see about the internal block elements of a 8051 IC. Building elements of 8051. These are the main internal building elements of an 8051 IC. Okay, what is this 8051 IC is that we all know that in an 8051 IC, we all are having a input processor or a CPU, memory, timer, registers, interrupts, everything are built together in a single IC. That is the microcontroller ICs and the 8051 IC. Okay, so this ALU unit is the processor unit, and this RAM and ROM for to store the data and programs. We are using this RAM and ROM as a memory unit. Control unit, which is mainly used to control the instructions or to convert the data into one instruction. For this purpose we are using this control unit. It will send the fetched instructions to a control bus. And we are having a ports and a latches. Already I have said that in an IC we are having a 32 IO pins. So to drive all those IO pins we need a port pin and a port driver circuit. That is the ports and latches. And this PC is a program counter which it will fetches the instruction. Okay, fetch the instruction from where? RAM. Next, PSW is a program status word which it gives the status of the program to the user. And this register banks, here we are having a 4 register banks. Okay, and interrupt and a clock, we are having 3 internal interrupts and 2 external interrupts. And a clock circuit, we are having a oscillator clock circuit. Okay, why we are using this particular oscillator clock circuit is that to produce the stable frequencies. And this A is nothing but a accumulator register or a general purpose register. B is a special function register which is mainly used for special operations. Data pointer is a 16-bit special function register, and special function register we are having. Special function register is that this is of 21 special function registers we are having in a 8051 IC. These are the main building elements of an 8051 IC. Apart from these building elements, we are having other building elements as stack pointer and some temporary registers, that is temporary registers 1 and 2, and also apart from this we are having a buffer circuit, program counter, incrementer, many we are having. These we will discuss about in a architecture of 8051 in a next session. Okay, these are the main internal building elements of a 8051 IC. This is the special features of 8051. Here we are having 8-bit CPU with registers A and B. Okay, this A register is accumulator register, this B register is a special function register, and we are having an internal ROM of 4 KBs we are having. That is 4 kilobytes of internal ROM we are having. This ROM is which memory? It is a program memory. Okay, and we also can extend this memory space to 64 KB in additional. Okay, and we are having a 16-bit program counter. Okay, and a data pointer. Data pointer we are having of, it is a 16-bit data pointer. Okay, it's a 16-bit register. Whether it can take full data pointer as a 16-bit register, or else we can separately we can have this for low order bytes and other 8-bit for higher order bytes. Okay, and here we are having a internal RAM of 128 bytes. Okay, internal RAM of 128 bytes we are having, and 8-bit program status bar, which it gives the status of the program to the user. Okay, it will give the status of the program. Status. Okay. And we are having two 16-bit counters and timers. That is how we are having this two 16-bit counters and timers is that TH0, TL0. This two will take one 16-bit. Okay, and TH1, TL1. This will take another 16-bit. So two 16-bit counters and timers we are having, and 4 8-bit IO ports we are having. That is 4 IO ports we are having. Each port will have 8 pins. So total 32 IO pins we are having, and 3 internal and 2 external interrupts we are having, and some control registers, and also an oscillator and a clock circuit. Apart from this, we are having a 8-bit data bus. Okay, 8-bit data bus and a 16-bit address bus we are having. Okay, these are the special features of a 8051 IC. See the block diagram of 8051. Already I have said we are having a 4 IO ports we are having. Okay, each port will have a 8 pins. Okay, 8. This will separately have 8 pin. This will separately have 8 pin. Okay, this will have 8 pin. This port will also have 8 pins. So total 32 IO pins we are having in a 8051 IC. Okay, all these ports are bidirectional ports. Okay, that's why we are having arrow in both sides. And this port 0 is mainly for IO port. Okay, it will perform IO port operation as well as A0 to A7 operation. That is, it carries the address lines operation, which we can use in external connections also. Port 0. In port 1, only it will perform IO operation alone. It will not carry any address lines. And in a port 2, It will carry IO pins and also an address lines of the order of A8 to A15. This port 1 and port 2 will perform the internal connections. Okay, this port 0 will perform the external operations also. We can connect it to the externally. Externally in the sense, what is called as the external IO pin is in our laptop, if we are using or if we are connecting a pen drive to the laptop, that connecting pen drive is a external device. Okay, that is an external connection. For that purpose, we can use this port 0 pins. Okay, so in our laptop, while we are connecting a USB cable or any input mouse to this input device is a mouse. Okay, so I need to connect that to the input port pin, then only it will access. If I want to connect a printer to my computer, I need to connect that to the output pin, then only it will access the output of the computer it is giving. Okay, so that is called as a port pin. Similar operation this 8051 will do for input and output pins. And this port 3 is a special function port. Okay, why it is called as a special function port is that apart from IO operation, okay, that is apart from IO functions, it will do interrupt, counters, serial data and rewrite operation also it will perform. Suppose if I want to use my laptop as a server, okay, if I'm going to use my laptop as a server, I cannot change that by using IO lines alone. I need some special function port pin to change my laptop to work as a server. For that special function purpose, we are using the port 3 pins. Okay, so my system can do any device, okay, but it needs some special port pins. For that purpose, we are using a special function port, okay, to make my device to other device I need, okay, to conversion of to do a particular task of what I need is that special function port. So to drive all those ports, we need some port driver circuit. Okay, these ports cannot run alone. It all need a driver circuit. That's why we are having a port driver circuit. This port driver circuit is otherwise called as a latches. Okay, latches is nothing but it is a flip-flop. Okay, so each port will have a separate port driver circuit. Okay, next here we are having a memory. Okay, memory unit we are having a RAM memory and a ROM memory. RAM memory we are having a space of 128 bytes. Okay, what is the special function register RAM is that if I'm performing an operation, okay, but I'm getting an input in a special function register that will be stored in the special function register internal RAM. So for that also we need some space. Okay, and a 4 KB ROM we are having. Here we are having a 8-bit data bus and also 16-bit address bus we are having. Okay, here is a special function registers. Total special function registers we are having is of 21 special function registers we are having. Okay, here we have given only 11 special function registers as internally. That is, I is an interrupt enable register, I is an interrupt priority, PCON is a power control, SBUF is serial buffer, SCON is serial control, TCON is timer control, TMOD is timer mode register, and this is for counter and timer mode. Okay, and this is a register bank. Why we are having this register bank in here is that if I want to store some data in a register, okay, before while execution I am getting many datas, so I want to put that in some registers. For that purpose we are using this register bank. This register banks are of 4. So among 4 banks, whether I can put in any bank? No, we can't put like that. Here there are 2 register selectors are there. Okay, that is RS1 and RS0. We are having a 2 register selectors. What this register selectors will do is, it will check where the data to be stored in which register. Okay, if I am choosing a 00, okay, if the register selectors both are 00, then it will choose a bank 0 register. Okay, if it is 01, then it will choose register bank 1. Okay, if it is 1 0, then it will choose register bank 2. If both the selectors are 1 1, then the data will be stored in register bank 3. For that purpose only we are using this register bank structure. Okay. Next here we are having a register, that is arithmetic and logic unit we are having, which will mainly perform the arithmetic and logical operations. Okay, it is a processor unit. Okay, this is the processor unit and which is the main and important unit. From this, all the data stored will be sent to the accumulator. Okay, this accumulator is called as the king of the register. Okay, this A register is a accumulator register, which is called as a general purpose register or a king of register, because defaultly if I want to save any data I can store that in accumulator, or if I want to send output you can store that in an accumulator. And next B is a special function register, which will take part during only multiplication and division functions. Next one is a program status bar. Already I have said what is the program status bar. It gives the status of the program to the user. Okay, it gives the status of the program to the user. And next one is a program counter. Program counter is the important play role in a 8051. What this program counter will do is actually this only fetch the data from the RAM. Okay, initially it will only fetch the data from RAM. Okay, that is the work of a program counter. Okay, it will fetch the data from RAM. Initially, if the RAM address is 000, that will be the first instruction fetched by a program counter. Okay, this program counter will always get incremented by 1, but it never gets decremented. Okay, the next one is a data pointer. It is a 16-bit register. Okay, this will separately have 8-bit, that is of higher order byte, and lower order byte will separately have 8-bit. Okay, next this is one is a timing circuit. Okay, this is a timing circuit. What is the timing circuit? Is the system timing and a system interrupt timers, data buffers, memory control. What is the system timing? Is that if I'm performing a task using a ALU, okay, I'm giving a work to ALU, but what I want to do is I need to complete that task in a time. Okay, I need to complete in a half an hour or a 2 hours after. Okay, so I need to set some time. That is the use of a timing circuit. Okay, that's a system timing. I can set the timing. Once the operation has ended or executed, this enable access will give information to the user that the task is performed, and this is ALE is the address latch enable. So it will latch the address from the execution point, and this is a program store enable. Once the programs are stored in a ROM, it will be set to a 1. Okay, till all the operations are performed, it will be in 0. Once all the operations are performed, it will set to 1. These two are the resonance circuit, which is mainly used to produce the clock pulses. Okay, what clock pulses? To maintain a stable frequencies. And this is the reset pin. Once every instruction is executed, this reset pin will reset the program counter. Okay, before starting a new operation. And this is the plus 5 volt supply VCC and a ground point we are having. This is the basic internal block elements of a 8051. See, this is a arithmetic and logic unit. What this arithmetic and logic unit will do is, it will perform mainly 3 operations. Okay, what are the 3 operations? Already I have said, it will do fetch. Okay, first it will fetch the instruction. Okay, next it will do decode the instruction. Okay, before processing it will decode it, and finally it will execute. These are the major 3 operations of a ALU. Okay, so how it will fetch the instruction? Let's see. See, this is a program counter. Okay, this program counter is what it will do is it will access the data from this RAM. Okay, program counter will access the data from RAM. Initial value is 000. Okay, initial value is 000. So it is the first address of this program counter. Okay, this program counter will always be incremented by 1, but it never gets decremented. Okay, and also this program counter can sometimes incremented by 2 or incremented by 3. Okay, if I want to increment my program counter to 3, okay, I can simply write as program counter equal to 3. This instruction is wrong. Okay, this program counter will not access if I write program counter equal to 3. Then how we can write? I can use the instruction LJMP to some address I am going to give, that is 8512. Okay, if I given an instruction to program counter as LJMP8512, what is this LJMP is? It is long jump to 8512. This 8512 is the address. Okay, and if I give like this instruction to program counter, at this case this will take a long jump to this address and access that instruction. When giving instruction like this alone, this program counter will get incremented to +2 or +3. Okay, otherwise this program counter will do +1 only. Okay, it will be getting incremented by 1 only and it will perform the task. That is the program counter. Okay, first initially the program counter accesses the data from the address and it's showed here. From this it's given to the address register, that is memory address register. What this memory address register will do is, it will through address bus, it will find the address. Okay, once it find the address, corresponding content will be taken. Okay, this corresponding content will be given via data bus. Okay, data bus to, it will be stored in a memory data register. Okay, this will store only the datas. Okay, this is the first cycle of operation. Okay, once the datas are stored in this data register, what it will do is, this data register will send that to the instruction register. Okay, this is the point of fetching. Okay, from address register to data register, we are storing the data as that, it is the fetching of instructions. Okay, once the data register fetches the instruction, it will be given to this IR. What is this IR? It is an instruction register. Okay, what this instruction register will do is, it will send this instruction to the control bus. Okay, it will not send all these 8 bits to the control unit. First 4 bits will be sent to the control unit. Okay, 0101 is the operation code that is sent to the control unit. This control unit will give the instruction. Okay, what instruction it will give us? It will give us load this data. Okay, after that, see, 0101 is to be loaded. Okay, first load this instruction. Next is 0100 is the operand. Okay, first 4 bits are the opcode and last 4 bits are the operand. Now what this operand will do is, once the instructions are fetched, this program counter will start to take the instruction, next instruction from the address. Okay, till fetching only, it will not take any instruction from the address. Once it's fetched by the instruction register, this program counter will get incremented by 1 and it will access to next instruction. That's why here it is a 001. Okay, in between what it will do is, this memory address register will store this data 0100 here. Okay, it will store this data and it will take the content, okay, through a address bus. 0100 will be sent as a address here. Okay, via address bus, and it will take the particular content through a data bus. It will be shown in next slide. See, that 010 is stored in a address register because this is the operand. Okay, only operation code will send to the control unit. This operand will stored in a address register. Okay, and this address register will access that particular address 0100 and it will take the content via data bus, that is 000 through a data bus. Okay, so that instruction will be stored in a data register. Okay, once this data registers are stored here, okay, what it will do is, again it will take the instruction as 000 and 001. Okay, for that it will be stored in a accumulator. Okay, this data register that will be stored 000 and 001 will be stored as a first data in a accumulator. Okay, this is the first data we have taken. To perform ALU operation, we need at least 2 datas. Okay, so next it will, once the fetching process is over, what this program counter will do? It will again increment. Okay, what is the next increment address here? 0010. So that is given in this 0010. Okay, so 0010 is given here, and here the memory address register has 0100. It's fetching that instruction only, 0100 as a first data. Okay, after that only it will do as this instruction. Okay, that will be, this instruction is 001 and 0101, that will be stored here as a data register, and that is given to the instruction register. First, this data is given as a first data, and next this data will be given as a second data. Okay, 0101. Okay, that is given to the instruction. Okay, don't confuse that. Program counter will get incremented once all the datas are fetched. Okay, it will not wait for the accumulator to store the data or the ALU to perform the operation. Okay, keep it in mind. Program counter will never wait to store the data to be in an accumulator, or the operation has to be done by ALU. Once the data are given to a data register, this program counter will automatically starts incrementing. Okay, this memory data register will send that to the instruction register, and this instruction register will then send to the control unit, and it will fetch us the instruction. Okay, so first we have taken a data as this 000001 as a first data. Okay, that is from the operand we have taken, and next we have taken 0100 value. Okay, that is 0000100. Okay, that is the instruction we have taken as a second data. Okay, and now these 2 datas will be fed to this ALU unit. Okay, see, this is the first operand value. 0100 is the first operand value here. Okay, next is 0100 is the second operand value here. Now we are going to add these 2 operand values, that is 000 and 001 and 000 and 0100. So that will be stored in this accumulator. Okay, so from this accumulator it is sent to the ALU unit. What does ALU will do? It's given a command as add. So it will add the 2 datas and store the data in a accumulator as 000 and 0001. That is the result finally we got. Okay. See, this is the ALU third cycle. Third cycle is that last cycle. Okay. The data are again fetched and it is stored here. Okay. This process still continued till the last data. Okay. This ALU will perform not only mathematical operations like addition, subtraction, multiplication, division. It will perform rotate operation. It will rotate the data. It will compare the 2 datas. Okay, it will compare the data and it will take complements the data. These are the operations that performed by a ALU. Okay, This program counter will always gets incremented, it will never be gets decremented. This control unit will give the instructions to the instruction register. What have to be stored here? Okay, this accumulator will temporarily store the data from a data register. Okay, and when all the operations are performed by ALU, it will store the final result in the accumulator. Okay, this is the ALU unit of a 8051 controller. Next one is a program status word and special function register. What is a program status word? Which it will give the status of the program to the user. This program status word have two flags, mainly math flag and a control flag. Okay, it has two flags. This math flag has 4 flags and this control flag has 2 flags. So 3 flags. 4 flags are carry, auxiliary carry, overflow and parity. These are the 4 math flags and these 3 are the control flags. Okay, this is RS0 and this flag is a reserved area. Reserved area means we will not do any operation there. Okay, so what is this carry flag is that? Carry flag is that while we are doing any addition or subtraction, okay, we will get carry or borrow. Okay, if I have any carry or borrow while doing operation, this carry flag will set to 1. Okay, if I don't have any carry or borrow, this will set to 0. What is this auxiliary carry is that when I am having more carries or more borrows, this auxiliary carry flag will set to 1. Okay, if not, it will set to 0. Mainly this auxiliary carry flag will be used in a binary coded decimal operation. This auxiliary carry flag will use. Next one is a overflow flag. What is this overflow flag is that only I have a capacity to store 32,000 around or 585 integers alone, it can store the capacity. Okay, but I am giving a capacity to store 57,000 or 55,620. This much integers I am giving to store in overflow flag. Is it possible to store there? Because it has a capacity to store only 32,585 integers in a overflow flag. But I am giving a 55,828 values to store in overflow flag. Is it possible? No. At the time this overflow flag will set to 1. Okay, when it exceeds the integer limit, and otherwise it will set to 0. What is this parity flag? Parity flag is nothing but just consider a number as 0001. Okay, these two bits are paired bits. Okay, these two bits are unpaired bits. Okay, when I am having a pair, this will set to 1. Parity flag will set to 1. When I don't have pair, it will set to 0. That is, when I am having an even number, it will set to 1. When I am having odd number, it will set to 0. That is the parity flag. Okay, these are the 4 math flags in a program status word. What is the control flag? We are having 3 control flags, that is F0, RS1, RS0. F0 is the user defined flag, okay, which is mainly used by a user. I can define anything to this user defined flag. RS1 and RS0 are the register bank selectors. Okay, if both are 00, then the value will be stored in a register bank 0. That is, it can store the from address 00 to 07. Okay, if it is 01, then I can store the data from 08 to 0F address. Okay, that's in bank 1. If it is 10, okay, then I can store in RB2, that is from 10 to 17. Okay, if both the register banks are 1, then I can store the data in a register bank 3, that is from 18 to 1F. Okay, this is about program status word. And here we are having some special function register. Total special function registers we are having is 21 special function registers we are having. Okay, the special, why it is called as a special function register is that the special function register will perform some special functions. For example, if I am using a B register, okay, this will only can be operated during multiplication and division operations alone. Okay, whenever I'm using a multiplication division, this B register would automatically come into program. Okay, that is the special function. If I'm using a serial port, then SCON and SBUF can use. Okay, if I'm using a timer, then all these registers can be used in a timer. If I'm using a data pointers, then I can use higher order or lower order. This is a power control register. Okay, this P0, P1, P2 and P3 are the ports. Okay, this is the interrupt priority and interrupt enabled registers. This is a program status bus, this is the accumulator, and this is a stack pointer. Stack pointer is the internal pointer, data pointer is the external pointer. Okay, these are some special function registers we have checked. See, next one is a data pointer and timer. What is this data pointer and timer is that this data pointer is a 16-bit register. Okay, it's having separately 8-bit for higher order and another 8-bit for lower order. Okay, this data pointer high is always be incremented, this data pointer low is always be decremented. Okay, in a very rare case, this data pointer high will get decremented. When means when this having a bits order lower than this DPL, then only it will get decremented. Otherwise, it will never decrement, it will always increment only. Okay, so to increment the instruction, we can use push DPH. Push DPH is meaning that it will increment the datas to a higher order. Okay, if I am using a pop DPL, is that it will decrement the data. Okay, push and pop. Okay, push means increment. Okay, pop means decrement. Right, and this DPTR we can increment the data pointer also. Okay, we can increment the data pointer also to store any instructions. Okay. Okay. And also we can use data pointer in various instruction as if I am having a instruction as move a comma hash 60. Okay, next I am going to move this data accumulator to a data pointer. Okay, accumulator to a data pointer I am going to move. So move DPTR comma A, which is that now the data will move from accumulator to data pointer. That is accumulator data is 60. Okay, move a comma hash 60 is that store the 60 in a accumulator is a meaning move DPTR comma A is that move that 60 to a data pointer. Okay, now I can give any instruction to that. After that, finally I am moving that from data pointer to the accumulator. Okay, move X at DPTR, move X at move DPTR comma A, that is from accumulator to data pointer we are moving, and from again data pointer, so move X at A comma DPTR, X at A comma DPTR. Okay, once all the operations are executed, that data will be stored in an accumulator. From accumulator I am going to move this to a data pointer. Why we are moving this to a data pointer is that to point out the main data pointer location. Okay, that is this data pointer is an external pointer. Okay, and another pointer we are having is it is a stack pointer, which is an internal pointer. That is, it will perform operations internally, it will perform operations externally. That is the data pointer. Okay, next we are having a timer circuit. Already I have explained that why we are using this timer. If I want to finish my task in a particular time, I need to set a time limit. Okay, so if I am setting a particular time limit, okay, once the task is completed, these LEDs will glow. Okay, otherwise this will not glow until the task gets over. Okay, next one is the memory organization of a 8051. In a memory organization, we are having two types of memory, that is ROM memory and a RAM memory we are having. ROM and RAM we are having. Okay. This ROM, embedded ROM is that it is a on-chip ROM. On-chip ROM is that in a single chip we are having a memory unit. That is a on-chip ROM. It has a space of 4 KB. Additionally, we can take 64 KBs from externally. Okay. Similarly, in a RAM we are having a 128 bytes of internal RAM, and I can additionally extend it from 64 KBs to 128 I can access. Okay. This is the basic memory organization unit. And oscillator and a timing circuit, that is oscillator and clock. Here we are having a one resonance circuit, that is a crystal oscillator. It is a ceramic resonator. Okay, this is pin 18 is a XTAL2 and pin 19 is a XTAL1. 8051 DIP is a dual inline package. Okay, 8051 is a dual inline package. Dual inline package. Okay, and C1 and C2 are the capacitors. It is of 22 microfarads. Why we are particularly using a crystal oscillator is that because this crystal oscillator will produce a stable frequencies. Okay, and it has a minimum frequency of 1 megahertz to maximum frequency of 16 megahertz. Okay, see, in a crystal oscillator it will be producing a clock pulses in a stable state. Okay, this is about oscillator and timing circuit. These are the basic internal block elements of a 8051 microcontroller. Okay, in the next video we can discuss about the other block elements also in detail with respect to architectural diagram of 8051. Okay, thank you.